We will solve this problem today. 452, minimum number of arrows to burst balloons. We have spherical balloons taped into flat wall that represents XY plane. Okay, the balloons are represented as 2D integer array points, where point of I is x start and x end. Denotes a balloon whose horizontal diameter stretches between x star and x end. Okay, so uh, what is being told is that we have a plane xy and there are balloons taped into that wall. Okay, and we have been given uh, these coordinates. Okay, these points, the starting and end for a balloon has some diameter. Okay, balloon will have some diameter, and for every balloon we have been given the start index, starting point of that balloon in x coordinate and the ending point. Okay, so x start and x end for each and every balloon. So we have a 2D array. Okay, and what we need to do, we need to shoot arrows vertically up so that so that the balloon pops, and we have to pop all the balloons that there are. Okay, so for example, if we have these many balloons, then we have to shoot arrows like this, and this balloon will pop, this arrow will pop all the balloons on its way. Okay, so here if we shoot an arrow, or here we shoot an arrow, this will pop these two balloons similarly. So we can pop balloons, and our problem is to find the minimum number of arrows that must be shot to burst all balloons. And also we have been given that uh, that arrow will keep on traveling till infinity. Okay, so there is no cap to how many balloons arrow can pop. Okay, so balloon arrow will keep on moving till infinity and it will pop all the balloons on its way. Okay, so let's see. So first of all, uh, I've already plotted the diagram, so let's see. Let's abstract it a bit and see. So suppose these are our starting and ending index of balloons. Okay, something like this. Okay, okay, for example, this can be some starting point, ending point, starting point, ending point of some balloon. Okay, some balloons. So now when we see this problem, we can think that, like, we can shoot an arrow here. Okay, we can shoot an arrow here, and we can shoot an arrow here. So what we can do is we can pop all the balloons in two arrows. Okay, I can't see any more alternatives. Maybe we can shoot an arrow here, but when we do that, we require two more. Okay, like this, and maybe one more like here. Okay, so this is not preferred. Okay, so we should this is preferred. Okay, in this problem, so we can, like, find two different things here, two very important points that we can note from this diagram. First is that we need some kind of ordering. In the problem, the array that we have been given, there is no ordering. Okay, like 10, 16, and after that 2 and 8 comes. Okay, so but in this diagram we can see that it is very easy if we, like, if we put all the balloons who are closer together nearby each other. Okay, so for this is a balloon which starts at this point and ends at this point. Similarly, this balloon starts at this point and ends at this point. We are keeping the balloons together which are together. Okay, so this is one thing we can note. So so now we can realize that maybe what we can do, we can sort the array. Okay, that we have been given, we can sort it. Okay, we can sort it. And one more point that we can, like, find is that that suppose if we shoot a point balloon here. Okay, we had something like this, right? We have some things like this, and we had, then I made something like this. So we can maybe use this one here. Okay, this arrow, and then but then we realize that we have to use two more arrows. Okay, just to pop these balloons. Okay, so when we think about it, then it is very apparent that we are getting an overlapped region here. Okay, we are getting an overlapped region here, and there is no point in skipping this. Okay, we should means we should try to find out if there are more balloons that are coming on its way, they are on its way. Okay, means there more balloons that overlap in this region so that we can shoot arrow. But when that is not the case, we should shoot an arrow here. Okay, there is no point in like searching for other areas where we can shoot, because if we skip this, nonetheless we have to shoot arrow here, okay, to pop this one. So whenever we get an area that is overlapping with some balloon, we should shoot an arrow there and we should not wait. Okay, and so what we can do in this problem is that first we need to sort, and then we can move, we can traverse the array, and we can find the overlapping regions, all the balloons that are in a particular overlapping region. Okay, and we need to shoot that arrow there. And whenever for the next balloon, if we don't see that it is overlapping with the previous balloons, what we can do is that we can consider is as a new region. Okay, this is our new region, and then we can continue further finding the balloons that are overlapping with this balloon, and we can shoot an arrow there. So now how do we find if two balloons are overlapping? Okay, so suppose this is one balloon, okay, and we have one more balloon. We can say that when this point the starting point of the next balloon is somewhere in between starting and ending of the previous balloon, we can say that there is an overlap. Similarly, there can be other conditions as well. For example, if the starting point can be at the starting point of the previous balloon, even that can do. Okay, or end point. Okay, so this can also be a condition, or even this can be a condition, right? So these are all the conditions. This was my like the previous balloon, and these are all the possible overlapping balloons. Okay, so now let's try to solve this problem. First of all, we need to sort the points. Okay, arrays dot sort points comma p1 comma p2 p1 of 0 minus p2 of 0. Okay, so what I have done is I have sorted my points array by the starting position, okay, in ascending order. So now let's initialize some variables. Integer left equal to points of 0 comma 0, integer right equal to points of 0 comma 1. Okay, so now we can also define a variable overlap equal to 0. This will count all the overlapping balloons. Okay, so suppose this is our first balloon and this is our next balloon. So if we find such kind of overlap, then our count will be increase our count by 1. Okay, like we have a initial balloon, and if we find that some balloon is overlapping with that balloon, we will say, suppose if one more balloon comes here, then like first this balloon came, and then after that this came, so there is an overlap, so we will increase the count by 1. And again, if one more balloon came, then again it is overlapping. Okay, so we'll increase the count further. Okay, for that we have used this overlap. Okay, now we will iterate through these points. Okay, for integer I equal to 0, I is less than points dot length plus plus. Okay, so now if points of I and 0 is less than equal to right. Okay, so this is the condition of overlap if we have an overlap. Okay, so this was our previous point, and this is our new one, and this point is somewhere in between. Okay, before right. Okay, before right, this was our right and this is before that. So we'll say yes, there is an overlap. And what should we do? We should put left equal to math dot max points of I and 0 comma left. Okay, similarly for right equal to math dot, it should be min. Okay, max because left should be max. Okay, this point, if this is a previous point and this is a new point, so this should be the max. Okay, and similarly for right it should be min. For min, points of I 0 comma right. Okay, and we can say overlap plus plus, and for else, if there is no overlap, we will say left is equal to points of I and 0. Okay, so this is the current point that we have. We are defining a new position, okay, new region where we will find overlapping balloons later on. Okay, so for that we are redefining our left and right. Okay, right equal to points I and 1. Okay, and then we will say return points dot length of points dot length minus, we will say overlap. Okay, these are the total point balloons that we had, and these are the balloons that were overlapping, so we did not consider those. Okay, or you can even think that we can think it as like arrows. We can put arrows here, and you can say that arrows plus plus every time, like you find a new initial, you reset the region, you say that you shoot an arrow at the previous region, and for that you can say arrows plus plus here, and you can remove overlap from here. Okay, and you can say just return arrows, but this is more intuitive for me, so I'm doing like this. Now let's run. Okay, so there is some problem, overlap. Okay, let's see. Okay, so actually I think I've done a mistake here. It should be points of I and 1, right? Yes, so now let's run. Okay, max should be left. For left, what should be my current left? So it should, so okay, so the problem is that I am starting it from 0, but I've already considered the first point. Okay, so because of that my count is getting incremented by 1. Okay, let's see. So for every value it is getting incremented, it is less than 1. Okay, it is less than 1, so that is the problem. So now let's see if it works. Yes, and this is a case that I want to like highlight. What I'm doing is I'm sorting. Okay, this is where I'm sorting, but when I'm sorting, uh, since my x and y x points are to the very extreme of int, okay, mean value and max value, so what is happening, it is overflowing. So for that, what should I do? I should not put it like this. I should rather put compare. Okay, integer dot compare. I should do this, and this will work fine. Okay, let's see, comma run. Yes, now it is fine. Now let's submit. And yes, it is accepted solution. Thank you.